All right, guys, welcome to our Unit 10 test study guide. I'll be going through the odd problems, and we'll let you guys do, actually, I'm going to do the even problems, and then I'll let you guys do the odd problems. All right, so here we go. So this is an exponential equation. I want to get this piece by itself first, so I'm going to start by adding 10 on both sides. I still need to get this piece by itself, so now I'm going to divide by -2. And then we're going to do a log on both sides. Next, we're going to use one of our log properties to take that exponent and slide it to the front. Then we're going to divide both sides by log 20, so I can start getting the r by itself. Now I need to figure out what this is, and I have to use a calculator for that. My calculator gives me 1.106. Then I'm going to subtract 6 on both sides, which gives me -4.894. And then I'm going to divide both sides by -6 to get the r by itself. And that leaves me with my final answer, which is 0.816. There we go. All right, so quite a few steps there, but that would be solving an exponential equation. Let's move on to number 4. Right. For a period of time, E. coli bacteria in a culture grows exponentially. If the continuous growth rate is 4% per minute and the current population is 177 million, how many minutes will the population be 253.7 million? All right, so first of all, we're noticing that since we have this key word here, continuous, we're going to be using this formula. The y represents the final amount. The p represents the starting amount. The r represents the percentage, but we want it as a decimal, so you'll divide it by 100. Also, you'll want to recall that the positive means that it's increasing, negative means that it's decreasing. And the t is going to represent some kind of time. Okay? So as I read this problem here, that's my r value. So r is going to be 4%, but we're going to divide that by 100, which is 0.04. And notice that we have the population is growing, so that means it's going to be a positive 0.04. That's my r value. My p value, the starting amount, they tell us is 177, and then my final amount, y, is 253.7 million. T is what I'm trying to find. So I'm going to be plugging in these 4 values, well, these 3 values, and I'll be finding the t value. So here's what that would look like. Plugging this in for the y, plugging this in for the p, and this for the r. It's a positive 0.04. I won't write the plus, but it is a positive. Now we're ready to start solving for t. So the first thing we'll do is we'll divide both sides by 177. And I end up getting 1.433. Next, we'll go ahead and log both sides. Next, I'm going to use the property of logs where I can put that 0.04 in the front. Next, I'm going to divide both sides by log e. This is going to be done on the calculator, and you get 0.36. Finally, we just divide both sides by 0.4, and we basically end up with 9 as a final answer there. Okay, so that is how we'll handle the word problems. Let's move on to number 6. We're going to talk about log equations. So when it comes to solving a log equation, the way that you get rid of a logarithm is by exponentiating both sides. That means I'm going to make both sides a power of the base, in this case 11. So it's going to be 11 like so. And then we have a property that says that this and this cancel each other out. Same thing over here. And then from there, we're just going to solve it like we normally would. So I'm going to start by adding 4k on both sides so I can get those k values together. And I get k equals negative 13. Now that might be an answer or it might not. It depends. We have to remember that when you have log equations where there's a log on both sides, you have to check your answer to make sure it's not an extraneous solution. And you do that by just plugging it in. So I'm going to plug in the negative 13 here. And you want to do it on both sides. Okay, so on this side we have negative 3 times negative 13, that's 39, plus 3 is 41. So that's good. So long as this number doesn't come out negative in the end, we're happy. So that's a good answer. Let's make sure the other side also comes out to be 41, and if it does, then we have a good answer. Negative 4 times negative 13 is 52. Take away 11 is 41. So those are equal, and there's no negatives inside the log, so that's a good answer, and therefore negative 13 is my solution. All right, let's go ahead and check out number 8. Now in this case, we have our log here, but we've got these other numbers outside the log. So before we start doing any of the fancy log stuff, we got to get rid of the numbers outside the log. So I'm going to start doing that by adding 10 on both sides first. Then I still don't have the log by itself. I need to get rid of this 10, and I do that by dividing by 10. Now we need to get rid of the log. And the way that you get rid of the log is by exponentiating both sides. So I make both sides a power of the base, in this case, 4. So it's going to be 4 log base 4 of 6n minus 1. And on this side, it's 4 to the 4. On the left, these cancel out, and I'm left with 6n minus 1. And on the right side, 4 to the 4th power is 256. So from here, we're just going to solve. Oops. And there you go. For this one, we don't have to check our answer. There's 2 times you have to check your answer to make sure it's not extraneous. One of them is what we saw in number 6. That's when there's a log on both sides. The other one is when you have a quadratic. But this problem is neither one of those things, so we don't have to check our answer. That's a good answer. Let's go ahead and check out number 10. Now, for this problem, you'll notice that we have 2 logs on the same side that are being subtracted from each other. When that happens, we're going to use one of our log properties. We can put those 2 logs together as one log if we use our property B. Property B says that if 2 logs are being subtracted, you can rewrite it as one log where this one is on the top and this one goes on the bottom. Next, we're going to get rid of the logs. We do that by exponentiating both sides. So we make both sides a power of 3. And the result of that is these cancel out, and I'm left with 3x over 8 equals 7. So when you have a fraction, what you want to do is multiply both sides by the denominator. That way, it cancels on the fraction side, and I get just 3x now. And on the right side, we end up with 56. And then we're going to divide both sides by 3 to get the x by itself here. So I end up with 56 over 3, and that's my final answer. Once again, for this one, we do have logs on both sides, so we should check our answer. So if I were to plug in my answer here, it was 56 over 3. I don't need to check these 2, though, because there's no x, so I don't have to worry about that. Here, if I multiply these, the 3's just cancel out, and I'm left with 56. And that's a good answer to have, so I'm going to leave it. All right? Let's go ahead and move on to number 12. Another subtraction problem. So once again, we can put those together as one log. If I do x plus 6 divided by x, that's this one divided by this one. Once again, we're going to exponentiate both sides. On this side, they cancel. Oops. On this side, you get 4. Once again, when you have a fraction, you want to multiply both sides by the denominator to cancel that out. So on the left side now, I'm left with x plus 6. On the right side, I've got 4x. And then we just solve from there. I'm going to subtract 1x on both sides. And then I'm going to divide. I get 2. I don't need to check my answer because it's not a quadratic, and also I didn't have logs on both sides of the equation, so that answer is a good answer. Let's take a look at number 14. On this one, we have 2 logs being added together. And for that, we have property A. Property A says I can put these together as one log if I take this piece and multiply them together. Now to multiply those, I'm going to have to do some kind of distribution. So that would be x squared plus 24x. So I can put these two logs together as one log. If I multiply these together, which I already did, and I got this. Next, we want to get rid of the logs, so we're going to exponentiate both sides. On the left side here, these two things cancel out, and I'm left with x squared plus 24x. And on the right side here, we have 81. And this is a quadratic. Anytime you've got a square in there, that's a quadratic. So when you have a quadratic, we need to move the number over like that. And then we're going to factor to solve this, or if you want, you could use the quadratic formula. I'm going to go with the factoring approach. First term here, last term here. We're looking for two things that make x squared. That would be x and x. We're looking for two things that multiply together to make 81. Now, you're probably thinking 9 and 9, but I'm already pretty certain that's not going to work. Let me think here. How about 27 and 3? I'm pretty sure that'll work. 27x and negative 3x. Yeah, so these are going to add up to make the middle number here. Okay, so we have x plus 27 and x minus 3. We're going to set both of these equal to 0 and solve. So for this one, if I subtract 27 on both sides, I get negative 27. And then for this guy, I'm going to add 3 on both sides, and for that I get 3. Now, since I had a quadratic, I do need to check my answers. I need to make sure that they don't make the log come out to be negative at all. Okay, so let's go ahead and start with the negative 27. Well, if I plug negative 27 in here, that's going to give me a negative in the log. So that's not allowed. So I already know that that's not a good answer. Let's try the next one. Let's plug in 3. Adding these together, I get 27. It's a positive though, so that's okay. And so there we go. Now I'm not going to simplify this anymore, but so long as I don't end up with negatives here or here, I know we're good. So we're good. That's my answer. So the answer would be x equals 3. The negative 27 did not work. It was an extraneous solution, but the 3 did work. Let's go ahead and take a look at number 16. We're being asked to graph this log function here. So when you want to graph, the first thing you're going to do is you're going to find your domain. You find the domain by taking this part of your log and making it greater than 0 and solving. Now remember, when this bottom number is a negative here, you're going to reverse your inequality around. So it's actually going to flip around like this after you do your division. Okay. Step 2 is we're going to graph the asymptote. It's a vertical asymptote. So that's my asymptote. X is less than 4, so I'm going to go where x equals 4. And I'm going to draw a dotted vertical line there, just like that. All right. Step 3 is to make a table of values. Now you have to remember, we're only allowed to use x values that are less than 4, so I'll start with 5. And then I'm going to pick another number that's less than 4, but I want to pick a number that's oh, I did that wrong. 5 is not less than 4. 3 is. Sorry. 3 is less than 4. Now I want to pick another number. The next number I want to pick, you could technically pick 2, but I told you guys to pick a number that's about 10 units away from the first number. So if I picked a number that's 10 units smaller than 3, that would give me about -7. So I would say let's go ahead and pick -7. Right? Now to find out what the y values are, that's my next task, is I need to plug my x values that I picked into the equation that I have there. So -3 log 3. And I'm going to plug in my numbers that I picked. So the first one I picked was 3. The first thing we're going to do is we're going to simplify inside these parentheses. That's 2. The next thing we're going to do is we're going to do change of base on this. That would be log 2 over log 3. And that's going to be a calculator thing. So let's go ahead and do our calculator part here. And I get 0.631. Next, we're going to multiply these together. If I do that, I get -1.893. Lastly, we're going to go ahead and add these together, and I get 4.1. Now, when I graph this, I'm just going to basically graph 4. I think that's close enough to 4.1. Let's go ahead and do the same thing now. This time we're going to plug in -7. So I'm just going to replace that 3 there with a 7. But all the steps are pretty much the same. This is, I'm sorry, -7. That's going to be 14 plus 8, which is 22. We're going to do change of base for that. And then we use our calculator. And that gives me 2.814. Next, we're going to multiply these together. And then finally, we're going to add these together. And that gives me -2.441. And I'm just going to round that to about 2.5 when I'm graphing. Okay? Oh, -2.5. So now we're ready for step 4, which is to go ahead and plot these dots and connect them up. So plot and sketch. So here we go. I'm going to plot the point 3, 4. So over 3 up 4. And -7, -2.5. Now, as you guys can see, these two dots are going to connect like that. And then after that, it's going to keep going up, but it gets flat against that curve. Now, the way it'll really look is more like a bending line here connecting these. So it's going to curve up like that. And that's what that graph would look like for that logarithm. And that's the end of it. All right. Let's go ahead and move along here to number 18. All right, so for number 18, pretty similar. We're going to start by finding our domain. On this one, we're going to divide by a -1. And when we divide by a negative number, the arrow of the inequality reverses. So it's going to be x is less than 5. Let's go ahead and do our little chart here. I'm going to put a vertical asymptote at 5. All right. Now we're ready to do a table. I want to pick a value of x that is less than 5, so let's say 4, and then I want to pick another number that's less than 5 that's 10 less than 4, so maybe like -6 would be a good choice. And then I'm going to go ahead and start plugging those values in to the function they gave us so I can find the y value that goes with it. So here we go. I'll start by plugging in the 4. Five minus 4 is 1. You could use your calculator for this, but log of 1 for any log is always going to be 0. So the answer for this one will be 2. All right, let's go ahead and do the next one. Plug in -6. Notice the double negatives there become a positive, so it's actually 5 plus 6, which is 11. We don't need to do change of base on this. We could just punch that directly into our calculator because we have the ln button on our calculator already. And that's 2.398, but we still have that negative in the front. So if I combine -2.398 with 2, I would get the following. It's negative 0.398. And I would probably just round this to about -0.5, because when we're graphing, we can't be that precise anyway. So I'm ready to go ahead and put the points on the graph. So 4, 2 would be here. And then -6, -0.5 would probably be like right about here. And so connecting it with the appropriate curve, it looks something like that. So that's number 18. Let's go and take a look at number 20. It says, use a calculator using the change of base to approximate this to the nearest thousandth. That means the third number after the decimal. So the first thing we're going to do is we're going to do log 43 over log 6. That's the change of base formula. And then we're going to go ahead and punch that into our calculator. When you're doing this, you want to remember that on your calculator you put these numbers in parentheses, and you get 2.137 as your final answer there. Number 22 says to condense each of these expressions using some log properties that we've learned. So if you want to look back at your, I think it was like, I'm forgetting which lesson it was, like 9.3 or 9.4, but it's the ones where we had talked about properties A, B, and C. So the first thing that we're going to do is we're going to apply property C first. Property C is the property where you take the number that is in front of the log and you make it a power of the number that is in the log. So that would be log base 4 of 3 to the 6th minus log base 4 of 2 to the 3rd. Next, we're going to use property B. property B tells us that if we have two logs that are being subtracted, we can put those together as one logarithm, whereby we make this the numerator and this the denominator. And that's the end of it. We can stop there with that one. So you always start with prop C, and then after that you're either going to do prop A or B depending on the problem. Let's go ahead and take a look at 24. Once again, we're going to start with property C. So I'm going to take this guy here and make it a power on the 5. This guy here and make it a power on the 2. Now this time, since it's a plus, we're going to be using property A. Property A tells us that we can put these two logs together as a single log. If we take this one and multiply it by this one. And that's it for that one. So it's just a way of rewriting the expressions so they're simpler. It's also helpful when it comes to solving equations and stuff like that. Let's go take a look at number 25. Now, when you have a log being divided by a number, that's property C. But property C works a little bit differently this time. We went into the why behind this in our lesson, but for now I'll just show you the shortcut. Basically, when you have a log with a denominator like that, we're going to take that denominator off and we're going to turn that into a root of the log up top there. So all of these are going to be roots of 3, or cube roots, I should say. Next, since they're all being added together, we're going to use property A. Let me write that over there. Property A to multiply all those together now in one log. Now another little rule is that when you have roots being multiplied, if they're all the same kind of root, what you could do is you could just make it one big root with all those letters on the inside. Okay, so that would be number 25. Let's go ahead and take a look at 28. It says rewrite each expression in exponential form. So this is the base, this is the power, and this is what they equal. So that's how you rewrite things in exponential form. They want us to evaluate this expression. So there's a few ways that you could do it that we learned in class, but for now, one way to do it is by making these things match. So instead of 64, I'm going to change that to 4 to the 3rd power. Then after that, we're going to use a property. I'm pretty sure it's property number 3, which we learned back in lessons 10.2 through 4. And basically, these things cancel each other out, and the answer is just 3. All right. Let's go ahead and take a look at the next one here. Pretty similar to the last one. We're going to start by getting this to be a power of 7. That's 7 to the 3rd power. But we don't like it being as a fraction, but we can easily fix that by just making it 7 to the negative 3, because a negative 3rd power is the same thing as 1 over 7 to the positive 3rd. After that, we can use property 3 to cancel these out, and my answer is just negative 3. Take a look at number 33. For this one, this is kind of tricky, but you can get 1 to be a 5 if you make it 5 to the 0 power. Any number to the 0 power equals 1. And so these cancel and you just get 0. Now another way you could do is one of our properties, I think it was property 2. You could look at that instead. Property 2 tells us that anytime there's a 1 here, the answer is just 0. So that's a little bit easier way to go about handling it. Next question. Number 34, we're being asked to find the inverse. All right, so the first thing we're going to do is we're going to put a y in the place of the h of x. The next thing we're going to do is we're going to switch the x and the y. And then we want to get the y by itself, and this is where the steps are all a little bit different depending on the problem, but for this first one here, I'm going to multiply both sides by the denominator first to cancel that denominator out. Next, I'm going to go ahead and add 9 on both sides. And then finally, I'm going to divide both sides by 8, canceling out the 8 there on the right side. And so I end up with y equals 3x plus 9 over 8. Now technically the last step is to replace the y with an h again. But since this is an inverse function, we put a little -1 there. And there's our final answer. Let's go ahead and take a look at one more that's like that. A little bit of a different setup of the equation. Same idea though. So step 1 is to replace the g of n with a y. The next step is to switch the y and the n. And the last step is to get that y by itself. In this case, what we would do this time is we would subtract 5 on both sides. And then we would divide both sides by -9. We could put the g back. I forgot about that. But now we're going to put the little -1 because it's an inverse. All right. And so that does it. That should cover everything that's on our exam. Hopefully that was helpful, and we will see you guys in class.